Well, we're off to the races and we're starting the most complicated project of my very short career. And this is going to be a 6x48 belt sander. And right here you can see a front and side sort of x-ray view of my planned design. I'm on design iteration number 6. Had never started because every time I started I found something else I wanted to change. So here we are. This is where we're at. So what I'm going to start with is the simple part here. In the outside case, it's not terribly simple because it actually has to be pretty accurate. But we got to dimension some stock. So over here, I have a big pile of aluminum that's rough cut to size, and we need to get it over to the mill and get it to very close to exact dimensions. I want it within a few thousandths because that will allow me to put this thing together with pins and screws to make it very sturdy. And I chose aluminum because number one, it's light, and number two, it has better dampening features than steel would. So I'm using pretty thick aluminum. Most of it's 1/2 inch, but the back piece that a lot of stuff supported off of is 3/4, and a couple other pieces are also 3/4, but mostly 1/2 inch. So let's head over to the mill and get started. Alrighty, so here's the first pair of parts. This is the top and the bottom of the belt sander, and I got to make 2 of these that are identical, and they're going to be one of the easiest parts, so we're going to start there. They can actually be clamped in the vise, and I'm going to mill them both simultaneously. I've used tooling plate because I know that it'll be fairly dimensionally accurate, and to be honest, scrap tooling plate at my metal supply place is like 20 cents a pound more expensive than regular aluminum plate, so why not have the dimensional accuracy at least in 2 of the 6. So one side of this has been sheared and the other side I cut on my bandsaw, and not very closely. So we're going to set the sheared part down first, and we're going to mill along the top. We got to get these down to final dimension, and then we'll try and put them sideways one by one and get them to final width this way, and we can move on. I'm going to, even though I could continue and do screw holes and whatnot while I'm here, I'm actually going to dimension all my pieces first, because it's a rather extensive project. Some of them, the only way to do it is to put them on the mill table itself without the vise, and to clamp them down, and I've made some jigs to make that easier. You might notice I put a pair of cant twist clamps on either side of this guy to hold these 2 plates together. That way I can machine them as a unit. Alright, so here's the surface finish. I don't know if you can see that. It's very pretty. So we've deburred it, and we're going to clean, make sure that there's no debris in the vise. We're going to pop it upside down and tighten it. And we're going to take our first measurement, because now I know the bottom's flat, and I can and the top is pretty much parallel to that. But now we can take off a little bit of that and make sure we've got a square edge to measure from, because we're shooting for our 5.5, which means I really have a whole ton of material still to remove. Not that I need to be anywhere this anal, but look at that, pretty darn close to 5.5 on the money. The other side is about 1/1000th larger, smaller, so there's a little tiny bit of taper. Not bad though, completely acceptable. So now we're going to try and I'm going to deburr these edges, which this got quite a burr on it. Lie it flat, and then we're going to do these sides. This is a 1/2 inch end mill, zircon nitride coated, and again, I would not have the quill down. Normally I would raise the table up, but I'm doing this so you've got a better view. So it's quite a trick using a micrometer this big. I've never done it before. Getting it so that it's stable is really a challenge. So it looks like we're a couple of tenths under our ideal amount, which is more than accurate enough. It was just fun trying. And another little tip there that I found is really useful. After you do your final pass, you'll end up with little ridges on here, and if you do a couple of spring passes, especially one with lube. You'll take that off and you'll get up with a really nice finish like that. So I'm going to take these pieces to be deburred, and then I'm done with these two. I've got a bunch more to dimension. I'll bring you back as they get interesting. Alright, so I have a bit of a quandary here. Truing up these pieces of aluminum was pretty easy because they fit in the vise both horizontally, and I could stick them up vertically to true the other ends up. But the remaining pieces, especially this bottom one, are way too large to true up in the vise. So I'm going to have to come up with another solution. I think I have a good one. I have these T-slots in the side of my mill here, and I'm going to create pieces of metal that go flush with the ground surface here, and they'll go up to a set screw, and the set screw will be able to push on a parallel, like a 1 foot parallel, and I'll be able to dial it in with an indicator and get it right on the money, parallel to this axis. Oh, look at that, a little bit of corrosion. I hate that. Anyways, so we're going to try and make those right now, and we will then we'll start truing some more material. Quick visit to the bandsaw. We're going to cut this in 2 pieces, about 4 inches long each, and then we're going to head over to the mill to square it off. Here's another interesting observation. These are the Costco microfiber claws, and they're absolutely excellent for cleaning off really smooth surfaces, getting off small particles, like especially like the inside of the jaws. But the same thing that makes them great for that makes them terrible when the chips are large, because these chips get into the microfiber and you cannot get them out. So while microfiber claws are really awesome for the small stuff, although it will be embedded in the microfiber cloth, they're terrible for the big stuff, and you need to remember that you might have particles in here like you can see, and if you go rubbing a sensitive surface you could scratch it. So just another interesting pointer and observation. I like them a lot, but they definitely have their limitations. Alright, up until now we've been dimensioning stocks this size and smaller so I could hold it in the vise, but now we got to start dimensioning pieces like this and bigger. And no longer is the vise an acceptable method. I could use a heavy-duty angle block and do them vertically that way, but then trying to square them up would be challenging. So I've come up with another solution that I want to give a shot to here and see how that works. First step, I had to take the emergency stop off of the base of the knee here so that I could swing side to side without running into it, because it does provide a block. Then I created these plates, and I have surface ground their sides so they're flat, put a set screw in them, and they are going to be mounted right in the side here, sticking up. So there are 2 of them. Next up, I put a parallel, a big long parallel, in front of these 2 guys, and I've got the set screws there in case I need to adjust it, but it's actually flat and parallel to less than 1/2 thousandth over a foot, so I'm going to consider that good. I use the same indicator setup here to test the vertical and make sure that it's square to the base, just so you know how I got the 90 degrees. So then I've got these guys, which are my spacers. And what I did is I bought some more of this ATP5 plate, which is a tooling plate, so it's ground on 2 sides to be pretty accurate. And I'm going to use those as my spacers so that when I mill I won't accidentally cut the table. So we're going to set our part up on here, and let me get this guy out of here. Alright, so a little bit of a change of plan. So I'm clamping from one side. I'm going to, this is an undimensioned piece of stock other than roughly in the bandsaw. So what I'm going to do is I'm going to cut this side, and I'm going to cut this side and make them square to each other. And I need to seat this a little better. There we go. And once I cut these 290, then I'll have access to the other 2 sides to cut final dimension. I've left it stick over the edge here just a little bit so that I'll be able to measure the final dimension of that guy. And this is thick enough plate that hopefully it won't vibrate too much when I just try and take a little material off. So this is all a big experiment at this point, so let's just give it a shot. We're going to take off a tiny bit of material on both sides and then flip it and then go to final dimension. We're trying a pretty aggressive pass here, 250 thousandths depth of cut, which is about half the width of the cutter. Seems to be handling it pretty well. I was checking to make sure there wasn't any movement, but it looks like my clamping setup is handling it just fine. So when I get there, I'll bring you back. Yeah, we're hitting pretty close to the limits of my table travel. We may not even be able to make this. Oh boy. Talk about just barely fitting. So now I just need to reset and do the other two sides, this time to final dimensions. By the way, for any of you watching, I'm using the quick nuts I demonstrated in one of my quick tool reviews because I can quickly pop these guys into the T-slot anywhere I'm at, even if there's something in between, and they come right in. They go in and out easily, but lock in place. Very handy. You can get these at McMaster Car if you're looking. You can get them where the threads go all the way through, or if they stop like I've got it done here, so it's easy to lock in place, because once you start to tighten, they automatically lock and grab. The last part of dimensioning stock is this last piece here, and this guy is a complicated piece only because it's so long. It's the maximum travel of the table, more or less, and it's really wide, so it's got to stick way off the end. So what I end up doing is I build a fence, and I use an indicator to make sure the fence is square to the y-axis of movement. And I put these big blocks, these are ground plate, so that they're parallel side to side. And I clamp one side, and then if I need to, I clamp both sides, but I haven't needed to so far. The plate's really stiff. If I clamp one side really hard, it works out okay. So let me get the clamping set up, final completed here. I've indicated it in, and we're less than probably a tenth over the whole length here. And I'll show you what we're going to do. So what I've done here is I machined this first side. I mounted this piece and I machined this side to give me a reference surface. Now I'm going to machine my second reference surface back here, and I've labeled my two reference surfaces, and then I will rotate this 180 and I will machine this one parallel to this one to final size, and then finally I'll machine this other side that you can't see over here that's over here to length, and that in the same setup that I've got here. So I haven't needed so far to clamp this side. The 1/2-inch plate is stiff enough that it doesn't even vibrate much while I'm cutting it, even when I'm doing a 1/4-inch cut on this material. So that's been really helpful. Anyways, I'm just going to set up for cutting, and I'll bring you back when I'm done. The whole point of showing you any of this is just to show you the clamping techniques I've used in case you find them interesting. So we're just taking a 25,000 skim cut here, and I usually keep my hand on here to see if I'm feeling any vibration, and I'm not. The other advantage of using the x-axis is I've got a power feed on the x-axis, and when I turn this way, it's 24¼ inches. That's a lot of turning of the handle. 100,000th per revolution. Gets kind of crazy. Alright, so I'm going to face this off, then I'll deburr this edge, and then I'm going to reorient this. If you were wondering how I got any accuracy out of the measurements, width and length-wise, the width is 12 inches, and the length is going to be 24.025. So how am I measuring that with any accuracy? No, I'm just kidding. Alright, so for the 20-inch, I have a 20-inch set of calipers here, so that's how I do the 12-inch side. And for the 24-inch side, I use these calipers, which are 40-inch. No, none of these are particularly big name brands. These are Fowler's, and the other ones are Chicago. They're accurate to within a few thousandths, but that's better than I need anyways. I'm just trying to see what kind of accuracy I can get. So we'll take these guys over and measure the 24-inch side and see how much we have to take off. All right, so here's the bulk of all of the dimensioning. It's the external case and enclosure, which is a structural part of the whole assembly, and that's why I use such heavy aluminum. If you were actually going to sell this, you'd never make it out of such heavy-duty materials and not aluminum that's so expensive. Really nice units are made with cast iron, but they're many thousands of dollars. So I'm trying to match that damp cleaning without resorting to cast iron. This is a lot easier to work with, plus cast iron is not so easy to come by. So there's a lot of pieces and a lot of hours. Next step is going to be drill and tap all these guys so I can assemble them together, and then we'll work on the final guts later. Hey, say hi to the little guy. Say hi, Massimo. Good boy. All right. Thanks for watching. Hope to see you next time.